Have you ever wondered how deep tech companies actually start? Well, we were too.
So in this podcast, we'll be interviewing scientists and entrepreneurs that have taken their ideas out of the lab and turned them into startups. I'm Antonia.
And I'm Christina, and this is Startup the Science. This podcast is brought to you by Enam Berlin, the Innovation Network for Advanced Materials, bringing together the brightest minds in material science. Visit us at enam.berlin. Hey guys, welcome back to another episode of Startup the Science. Today we're speaking with the startup Motorskins.
Yes.
They're based here in Berlin. It's a 3-person team. We're talking today with 2 of them, with Juan and Facundo, who is also known as Kufa. Is that right?
Okay. Exactly. Which is why he will be referred to with both of those names. So we just want to clarify that so it's not confusing.
Where are they from again?
Different places, but Latin America, different countries in Latin America. What they do is a medical device. They work in assisted technology, and it's a textile technology. They'll tell us more about it. But the point of their technology is to help people with disabilities, and in particular with the product they're developing now to help people walk better. So if you have difficulties bending your knees,
if you have a spinal injury or something like that. Yeah,
exactly. And it's pretty cool. According to their website, you can power your legs by harvesting the energy of your steps, and then each step will power the next one.
Crazy
stuff. So they're quite fun. They are based here in Berlin, as we said, and they are at the moment and probably for the foreseeable future based in Motionlab. And they wanted us to give a shout out to Motionlab, who's supporting them. So Christina decided to sing. So Motionlab is a co-working and a maker space here in Berlin. They're quite cool. They have a lot of other fun, interesting startups developing cool technologies in their space. And they are big fans of Motorskins and supporting them in many different ways. And then Design Farm in Berlin is also supporting them through kind of like a scholarship for startups that they're helping them get. So we wanted to thank these two, Motionlab and Design Farm, in the name of Motorskins.
This was not a paid advertisement.
No, we're unfortunately getting no money for this.
Because we are not paid very much for this podcast. I'm relinquishing my mic to the guys, so you won't hear me much in this episode, but that's okay.
You will hear 2 other people.
Instead, yes. 2 for the price of 1.
All right, so let's talk to Juan and Facundo. Hi, guys. Welcome to our podcast.
Hi, we are very happy to be here.
Hi, thank you for having us.
We're also very happy to have you. And I think you're definitely the first startup that we have in this field. So today we're talking about assisted technology and medical devices that help with that, I guess. You obviously know a lot more than us in this field. So we'd love to hear from you maybe what is this all about? What is assisted technology? Who does it assist and how? Tell us more about it.
Okay, so yes, essentially Motorskins is a fluid-driven exosuit that helps people with motor disabilities to walk. When you ask me about the field, it's a little bit tricky because it started in the context of this cluster of excellence, image knowledge and Gestaltung at Humboldt Universität, where they had like this crazy idea of putting together people from the natural science, from the humanities and designers to work all together. So that was the starting point of the project. And as a field, the general field is assistive technology, as you said. That is any kind of product or device that it's aimed to help people with disability. If we narrow down a little bit, we're working with exoskeletons that are external structures that support the body on one part of the body to assist movement. And they are like really amazing machines. They are state-of-the-art orthesis, but yet they have a problem that most of what we call like the traditional approach to robotics, let's say, is still an assembly paradigm. That means that they have a lot of specialized components and a lot of specialized materials that goes together to perform complex function. Let's say the same way you will assemble a car. And that's, well, you can imagine that results in a great complexity, but also high energy consumption, both in use and in production, and last but not least, in high price. So many people cannot afford these solutions.
So we were talking now about classic robotics, you said.
Yeah.
So these are any kind of robots or devices made to, for example, assist people with disabilities? Is that what we're talking about?
Yeah, and in general, the way we build stuff. So most of our thing, I'm sure you have been some kind of funny video of robots that walk. You know, they are still kind of clumsy sometimes because there is a difference between how you articulate rigid frames with articulations and how the human dynamic is. So another field that is closer to how we move is soft exoskeletons, also called exosuits. That is what we are doing. So this is another approach. Instead of rigid frames, you have like textiles product. So they adapt better to the human locomotion, and they are safer and also potentially cheaper. And most importantly, they match really nice with another field that is growing a lot, that is soft robotics and fluid-driven actuators. That is robots or actuators that use a fluid, let's say they can be hydraulic or pneumatic, to perform a movement. So far so good. We really like this. We research a lot of that kind of solution. The problem, let's say the white elephant in the room, is that all of them are generally connected to a hose. And this is not a drawback per se, let's say for applications in a lab or even some industrial application, but an exoskeleton is a mobile machine. In a mobile machine, either a mechanical or a biological one, the maximal traveling range is related with the supply of energy to perform the movement. Let's say in a car it's fuel, or a battery in electric motors, or fat in an animal. So we decided to focus in autonomy in a way to assist in human locomotion. So we wanted to develop an exosuit that can harvest energy from the environment. That was the concept. And that's where the inspiration appeared to save us. So we were working together with people from the Max Planck Institute for Colloid and Interface in Potsdam. And there, where among many other things, they are studying how plants move, and it's called hydroactuated movement. And particularly we focus in the ice plant seed capsule, which is a small seed that can open and close as a reaction to humidity.
Okay, so you're drawing inspiration from how plants work, right? From nature, to build a robot that would be able to, or is it a robot? Or am I saying
in a
that?
broad sense, yes, it's a robot.
Robot that can harvest energy and then be autonomous.
Yes.
Am I kind of unpacking that? Okay, because I was trying to understand. I was trying to understand a bit better exactly how this technology works in real life. So from what you said, what I gather is most of the technology that exists now in this field needs some kind of power supply, right? It needs to be connected to a power supply at all times in order to work.
Yes.
And you're working on something that won't require that?
Yes.
Right.
Yeah, exactly.
Okay.
And it's not only about like the technical difficulties, it's also about the prices. Like it's really difficult to have these kind of technologies to be used every day for almost everyone who has problems with disability, because it's really expensive, and in the close future we will not be able to use those kind of technologies. So we are going in a different direction that is more close to microfluids, and we are trying to escalate that way to thinking to do something that is going to be portable for more people.
So let's talk a bit about this inspiration from plants or from the natural world, because that seems very interesting. So how does that work? We notice that, for example, a plant works in a certain way. How do we then steal that technology and put it in a robot?
Okay, yes, that's a very good question. Because generally people ask, why would you get inspiration from a plant and not from an animal, for example? And I think the answer is this seed, for example, we were talking about. What I found particularly interesting is at the moment that it performs this complex reversible movement that is in the floor, is technically dead matter, so there is no metabolic rate. And I thought that this would be like a really nice feature to develop an assistive technology that is energy efficient. So in the seed, this happened mainly because of two principles in a material base. One is the cellular organization into a roughly regular honeycomb pattern. That is to say, like all the cells are aligned in a way that they transform an isotropic swelling because of moisture into an anisotropic movement. This means that you, depending how you arrange them, you can program it to the same stimuli grow more in one axis than the other. And that's from a design point of view is very interesting. It's what they call metamaterials. So you can program features in the material organization. And the other principle is the V-layer that is following the same logic. So you can put two layers and one grows more than the other. You will produce, instead of a linear growth, for example, a bending or a twisting. And that's how you can see like this, the pine cones, for example, how they open.
So do you change the structure of the material, or do you? How do you achieve that? What's the process?
That's it. So the challenges from going from there to what we're doing were many, especially related with the scale, for example. So we are not working in a micro or nano scale. We're working within millimeters. The time, because for example that seed takes between hours or even days in opening. That was not good for us, and the nature of the stimuli, let's say, it's not useful to develop a system technology that moves with humidity.
Yeah, so we are using actually a digital fabrication with laser printing and CNC technologies to create certain kind of circuits by fluid that perform movement. It has this kind of building blocks by inspiration that Kufa was talking about.
Okay, and the final result then is?
Okay, so the problem we're tackling is like assisting the bending of the knee in people with motor disability, no?
Right.
Okay, a footnote is like motor disability is kind of a broad term because it can cover like many different situations, like people that suffer an accident, people with poliomyelitis, or just elderly.
So anyone who has difficulties in moving their knees, essentially, in bending their knees?
In bending the knee, yeah. So it's mostly our early adopter. The case we're working right now is people with a spinal cord injury that is a low one, so maybe at L3 level. So it means that the motor and sensor function are affected and cannot bend properly. So while walking, we have like essentially two main stages: the stance, where your weight is on the foot, and the swing when you move your foot forward. No? While swinging the leg, you have to bend a little bit. If not, you hit the ground and you fall. So that's the problem we are tackling.
Yeah, so at the end, the final product will be something like a sock or an exosuit that you will wear under your pants and will assist your gait.
So, for example, to define a little bit better our user, a classical example would be someone that had a spinal cord injury, can walk. For example, it feels comfortable enough for walking inside of their place, but when going outside, that poor bending makes that they cannot climb a step, for example, or they can fall because of some irregularity in the ground. So they generally rely on crutches to walk.
Okay.
So crutches is the simplest solution that the market can go, since exoskeletons are just too expensive for these cases. The problem with crutches is that they impair the use of the hands. So while using, you cannot use your hands. They can produce lesions, like in your elbows, for example. But with disability, there is like this physical aspect, but there is also a lot of social barriers, let's say. So, and all the social pressure related what normal is, for example. So it will be an improvement to have this kind of exosuit that goes underneath your pants, so you can just
nobody
walk,
needs to know you're wearing. So it helps with the physical part, but also with the social, maybe psychological damage that physical disability might have on someone. That's amazing. And so these kind of products already exist on the market, apart from yours?
There is the state of the art of exoskeletons are going in soft robotics. So it's mainly textile-based technology what they're building, but I think we are the first ones that are working in fluid-based technologies for assistive technologies.
So let's talk a little bit more about...
At least in Germany.
At least in Germany, okay. Let's talk a bit more about that. What does it mean that it's fluid-based?
Okay, so essentially we are transferring pressure from one part to the other. There are many fluid-driven robots, but the gap that we discover and what we're working is that we are a closed system. So we don't put like new fluid or more pressure. We work in a closed cycle. Essentially what we do is this. When you walk, when your foot hit the ground, there is potential and kinetic energy. So what we do is we design this hydraulic circuit that transfer the pressure from the heel to a second chamber that we call the storage chamber that has an inflation, an elastic deformation that stores energy. And then when the user has the intention of giving the next step, that energy is released and swells a chamber that assists the bending of the knee.
So each step kind of powers your next step?
Mm-hmm. Exactly.
That's very cool.
So you don't have to carry an energy supplies because each time you produce the energy again.
So the energy from one step is enough to power the bending of the knee. Is that right?
Yeah, there is a ratio.
Sorry, I'm simplifying it maybe too much. I'm just trying to understand in normal terms.
It's perfect. and the reason why it works, and when I say like this sounds simple, is because let's say I'm 80 kilos, so I put all my weight in my leg while doing that step, and then I only need to lift 5 kilos from my leg. So that's the ratio that enables us to store the elastic energy that is powerful enough for bending the knee.
And so does that mean it works for any person because it's always relative to the person's weight? And I mean, the effort that it takes for one person to bend their knee is relative to their own weight, so it works, or not so much?
I think it's part of what we're doing right now. We are working on our first MVP. We have a proof of concept right now. So part of the things we are going to do right now is actually have a medical test. And to answer that question in a proper way, I think we need to do that.
So what we are doing now, this self-synchronization of the product with the human gait is what we call an event-based energy cycle. We produced that, we developed our first proof of concept, and now we're working, as Juan said, in our first MVP, so something that you can try. And then we have to perform the user trials and the optimization. But we are working with 3 people in the team. Jose, that is not here today, he's a chemical engineer and he has a PhD in material science, so he's putting like the
engineer part of that. He knows how to build stuff.
Okay, so we're pretty confident that it's going to work, right? I mean,
we know already that the system works.
Yes.
We have to optimize it now. And that's one thing that is also part of a unique selling proposition. That is, in disability, each user is unique. So as we said, there are like many different situations. And that's why one of the reasons why it's so expensive, because you cannot mass produce generally. We make use a lot of digital fabrication. So we laser cut, we CNC seal with an ultrasonic machine, and we 3D print. So that means that in the future, we're going to develop a software where you can tune to each specific user to give the best answer.
I was going to be actually my next question, what else you're working on, or because it's so customizable, right? It's one solution for each person. If you see it being mass produced, or if you see it being like as a business, how would it operate? I guess you would use the software to then be able to customize the hardware part of it, or would you build a custom one for each user?
I think digital fabrication, that technologies that we want to use, allow us to actually have for each case produce product. But our client, we will sell directly to the Krankenkasse or the insurance, not directly to the user. This is like our first.
So your customers would be the
health insurance.
Health insurance companies. Okay, so the German Krankenkasse, I was puzzled. Okay, that makes more sense. Yeah, all right. And as a final product, do I imagine, is it just like a sock that you just put on? Is that kind of how I can imagine? Like a tie.
That is multi-layer. So the more layers it has, the smaller you can do the hydraulic circuit and the more efficient it is. So we are working on improving the resolution. But yes, you just wear it and it's just transferring the pressure from one.
So it's very intuitive and anyone will be able to use it easily.
And maybe addressing the question you did before, we are not tackling now lower limbs, but we could also tackle other kind of movements, because this technology allows us to perform extend movement, contraction, and other kind of complex movements.
So it could also be used as a glove, for example, in the future for your elbow or something like that.
We have to see what's the first income of energy, but I think that was the spirit on the name also, because it started working as to assist a lower limb, but when we saw the result, we saw that it's actually a principle. So it's some kind of machine that later we can use to perform many different things. So the concept of Motorskins was that we have a system that can harvest energy and transform it into useful movement. And then we see what we do with that.
I guess one of my maybe final questions on the product itself. So it helps with the movement when your movement is impaired. How does it affect the user long term? Is it also a form of treatment in a way, or is it just an assistant?
That's a very good question. Yes, so far we are working with chronic situations, so it's not for rehabilitation, but on the long term, it could work as rehabilitation. Because what happens today, because of the physicals and also social constraint that we talk is that people is moving less. So you have a problem, so you decide not to go, you decide to stay at home. So the less movement you do, the worse the situation it gets. So if you develop something that is simple enough and affordable so that people feels more confident for going outside and walking, it's going to work in the long term as rehabilitation.
Right, that makes a lot of sense. That's very cool. And is that what makes you most excited about working on this? The fact that you could help probably millions of people feel better and walk better?
Yeah, of course. I think it's a great motivation for us to actually offer something that could help that much people. But also, I think it has been amazing to work together with Facundo and with Jose, because we make a great team together. As we were saying before, Jose is not here, but he's like the engineer part of that. Kufa is the designer of the user center professional, and I'm in the business part of that. So we complement very, very good.
That's great. So you have someone for each part of the business. And it's a 3-people team right now?
Yes.
All right. And you're probably going to grow more, I guess, in the future.
Yeah, right now we are, as we said, we were working in our first MVP. We got the Berliner Startup Stipendium, that is like a grant to develop our idea first. But we are right now working in Motionlab, prototyping and working there. And in the future, we will be more people, of course. We're looking to cooperations with medical institutions as well.
That's great. So maybe we can go a bit more into that and hear the story of how it all started, how you guys came about this idea, how the team was formed. What is the story?
Well,
Okay.
Who wants to take this question?
Then I go.
Should be you, yeah.
So we met 3-4 years ago. We were doing this master in interdisciplinary research. So the way I say it is like how design can participate from scratch, let's say, from the very beginning in scientific research and not as the last actor in a very long chain. And I was developing my master thesis related to this, but just a proof of concept. And when we finished, we saw the potential, and we also the potential of this team that Juan was mentioning with a very different approach. And we decided to start walking the startup path. Then we met Jose, also like for networking with the people from Adlershof and Humboldt University, so with a more technical background. And we started presenting the project, and we had like very good feedback because
it's a cool product.
It's a cool product, it's a real problem, and it's really like a novel approach.
Yeah, and I think it was also about how to tell the story, how to tell the project, because it's a really technical field, and then to make it really easy to understand for the people who is not technical, it was a challenge. And we began to tell this, as Facundo said, a lot. The first one was in Berlin, Falling-Walls in Adlershof in Humboldt University. And we pitched a lot our project, trying to get funding, trying to get support, and eventually we begin to actually got that, and that's the stage we are right now.
And now you're in Motionlab, and you're about to formally register the company at some point and become a proper company. Right?
Exactly. We also we were part of Single Business Lab. That was like an accelerator here in Berlin, and we won the best Kickstarter in the Berliner newcomer startup scene, 2018. Nice. And we are part as well of Design Farm from
Weissensee.
Sorry. And so now we are in the process of what kind of company we want to be, where we want to be. So it's a lot of questions that we need to address. Yeah.
And can I ask, because based on your accents, I'm going to guess you're not German.
Sorry.
No, I'm just saying you don't have a German accent. So why Berlin? Why did you choose to come here?
I think, well, as Facundo said, we actually meet in Argentina, in Buenos Aires. Facundo is from Córdoba in Argentina. I am from Colombia, from Bogota. And we met because we began to do this master in the University of Buenos Aires. And then we came together to do the master in Humboldt University. And we met Jose, that is from El Salvador, but he was here in France before. So it was just a mixture of between Latin American conquering Europe.
That was so ignorant of me. I thought you were from Spain, but okay. I think you get that a lot, probably. Okay, interesting. Nice. And how did you find Berlin as a startup city?
I think it's amazing the way that the openness about everything you can talk. You can have any kind of idea and you can build something around it, and it's great. I love the people here. I love the possibilities that you have. Also, the support sometimes from the government is great. Yeah, it's a great experience.
We think so too, and we're trying to get more and more startups to come to Berlin. So it's good to see you guys are here. It would also be great to see you in our next accelerator program, which we talk a lot about on this podcast. So it's in September, and we'll tell you more about it post podcast. But we just wanted to plug that in so that it's official that you have to do it.
We are for sure going to apply.
Great. Wonderful. Is there anything else that you would like maybe to tell our listeners about what you guys do? Is there any particular maybe need that you have right now that you'd like to make more public?
I think we are really open to get any kind of support in the field of medical devices. If someone actually is working in this field, especially in the gait analysis, will be amazing to contact us. You can find us in motorskins.com.
Motorskin.com. Okay, we'll also put it in the description.
Thank you.
Okay.
And maybe also we are open to get the funding. It's always like a big need.
So are we. So I'm joking.
Yeah, but basically that.
Okay, great. And they can also find you in Motionlab if they're walking by.
Yeah, we are already there.
Thanks, guys. I think that's a wrap, and we'll see you soon.
Okay, perfect.
Thank you so much.
Thank you for having us here.
Thanks for listening to Start Up the Science.
If you like our show and want to know more about what we do, check out our website at inam.berlin.
And don't forget to leave us a review. Until next time.